Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to see how to build a very simple CLI in Rust, right? So some time ago, we saw how to work with StructOps, which is a very nice Rust library. But we want to see in this tutorial how to also work with it, right? So StructOpt is also similar to clap. So in case you know StructOpt, it's easy for you to work with clap. So let's see the library we're building, a simple package. So the name of the package is called Convertx, right? So if I go with convertx.help, as you can see, this is Struct. I've already compiled it, installed it on the system globally, and you can see that we get some information here. So multi-purpose unit converter. So in case you want to convert units from area, bytes, data rate, help, length, mass, pressure, speed, temperature, and time, you can easily convert it out of the box, right? So how does it work? So the main idea behind this tool is this: is that you can simply do something like this. So I can just go convert s, then let's say I want to convert my bytes. So bytes here, I can just specify that, okay, if I go with the help, I get the information. So we have the human readable and then a megabyte. So I can just go back to here and say that I want to specify a number that I want to convert. So I want to convert this value to megabyte, and then you get this in megabyte, which is very easy, right? And then in case I want the human readable, I can also do the same thing, arrow, and I also get this one in the human readable. You can see the difference, right? So this is megabyte, but this is the human readable, so 1.7, right? So this is 1 gig. Very cool. I can also try the same thing with, let's say, in case I want to convert seconds, so there is time, I can just go with the human readable, and this converts this entire time from this. So this is a number of days, right? And the number of hours for this particular time. So in case somebody leaves 86442 days, so this is going to be, you have left for about 1000, right? 10,000 days. Perfect. Let's see another stuff we can also do. As you can see, we can also do some conversion. So convert x, we can do conversion here. For example, we have length, we have speed, temperature, time. So in case I want to check the one for length, I can just go with the length, and you see the units. So there is from and to. So the possible values are meters, feet, and inches. So in case I want to convert x, right? So I want to convert from the length, as you can see, then you specify the options and the value. So I want to convert from, let's say, meters to, let's say, feet. So how many meters makes a feet? So if I go with this, you see the value. So 1 meter, this amount of feet. In case I go with 100 meters, how many feet makes 100 meters? So this is right. So this is a very simple tool. So let's see how to build this from scratch using Rust, right? So I'll go back again to my workspace here, you can see, and then this is the previous one we did some time ago. As you can see, this is quite some time ago, the beginning of the year, right? Very early. Now, yeah, so let's see how to build a new one. So I'm just going to go back here and go with cargo, new, then I'll give the name of it. So let's call it as Convertx, right? So later on we're going to store it later. Then it's going to create a binary here, and if I check it here, you can see that we have it here, right? Then I'll move into my Convertx, then let's open with VS Code. I'm trying to write some code, so I'll bring my VS Code here, and then let's close my browser, right? So we are trying to build using Structopt, right? Which is very cool, and then we want to follow this particular option. So I'll go back here, and then let's come back to our repository here. You can also use Cloud Code and any of them to help you with that, but yeah, we will still want to do everything from scratch, right? So I'll come down here. So this is going to be my main.rs. So later on we can just give it a good name, but we need an entry point. And then I am also going to create, in this location, I'll create my readme.md, right? And this readme here, you can just use any of the LLM tools to give you an example. So this is going to convert x. And let's talk about the usage, right? So how do we use the package? So the main idea behind how the package is going to be is that we have my bash, then it's going to be convertx dash help is the default one, then convertx. Then you also want to specify the command, so let's say byte. Then I want to specify the units that I want to go into, so it can be megabyte, and then the value, right? Whatever the value I want to be, right? So the value can be let's say 100, right? So something like this. You also want to be able to do convert s byte 100-r, right, for the human readable. That is one. We also want to be able to do convert s. So you say I have some length, then I have from, so we can go with from like this, or f, right, dash f. Then we can specify that I want to convert from meters to, so 2, or something like this, to a particular unit. So let's say feet, right? So something like, so this is going to be the basic stuff we want to do. So something like this, and then something like this. So how do we do that? I'll go back again to my location here inside my main.py, and not my main.py, main.rs, main.py, always Python. And then let's start from scratch. So first we'll be using StructOps. So use StructOps. That is the name of the package we are using. We are and the StructOps is very simple and very powerful because it gives us the option to be able to do a lot of things like click. Then I'll just go with my StructOpt, right? So this is the name of the package, and then as you can see, this has been underlined. So for us to be able to install the package, I can come down here and let's open it. Let's go down here. Then once I come here, I can just go cargo, add StructOpt. So this is one of the ways, or you can just simply go to the toml.yaml file and add it here, right? But I prefer this option here, and now you see that it has been added perfectly, and then this is gone. So that is all. So that is the basic understanding. So first, once you are done with it, we're just going to define our constant. So there are some constant that we need. So something like fit in meter. So what is the constant fit in meter? So fit, so we want to get it as 64 bit. Then I'll give the value 3.2.88. This is where you can just use LLM to help you with it, right? Something like this. So we define all the constant that we want to use, right? So I'll just specify the constant. So these are constant that I always use, it doesn't change. So here, right? So we have feet in meter, inches in meter, kilogram in LB, right? And then ounce, BPS, Kelvin, offset, right? So these are constant that we need. Then let's build the simple basic workflow. So first we will go with my Enum, then I'll call it a CLI. Then this is going to be my Enum. So as we saw in here, we have byte length. So these ones are sub commands, right? So this one is a sub command, this is a value, this is an optional argument, right? So let's go back again, and then because it's sub command, we use enums for sub commands. So for sub commands, right? So we come back here. So inside my CLI, I'm just going to go back here and I'm going to specify that, okay, this is how to make comments. So the 3.1 means use it in the documentation. So convert to byte, or convert byte values, right? And how do we do that? We just simply go with this. So I'll call this byte. This is an enum. Then inside here, I'll just specify the stuff. So I need a number, and the number is going to be unsigned integer 64. Then I also want to specify, so I can just make it better. So let's call it as a number bytes, and then the next one is going to be, I want to convert, so convert bytes. These are all the documentation to megabytes. Somebody would be saying that why am I not using LLMs to do this? Yes, it's true, you can use LLM, but yeah, we sometimes have to store code, right? You should not keep, LLMs are very useful, So I'm going to convert bytes to human readable. So these are the main stuff. Now we need this value here because in our readme we have -m, right? So how do we do this -m? We just have specified the byte, which is going to be the subcommand, the value that we want to pass, and a subcommand or the optional argument. So to do that, just go with my megabyte, and this megabyte is going to be boolean, right? So I'm calling it as boolean because we are just specifying it. We are not putting any value there, so we are just specifying this. So in a way it's a flag, right? So we are not, it's different from this, in which you have this and then you specify a value here. This is just true or false if it's available. That's why we are making it boolean. Then I need to convert this entire stuff into something that can be used, right? Into extract, into an optional argument. So we do that with this. Then I'll just specify that I want to use a StructOpt decorator or the macro. Then I'm going to decorate this and specify the short. So short is automatically going to pick the first letter as the short form, but you can specify it, right? So I can just come down here and then specify this one, or long, right? So the long will use a full name. So this one here, the reason we are having this error is that we need to decorate our enum also, right? So we decorate it with my derive because we want to be able to print. So we just go with the structopt and then debug so that we can print. This is the first stuff. Then we also need to specify again that this is supposed to be using. So we have structopt, and then I'll specify the name. So this is going to be the name of the package. Let's give it a name as Convertx, and then you can just give it an about, then call it as multi-purpose unit converter. So why is it giving us this error, right? So why is this error coming? So let me take off this. So the reason we're having the error is that, let's put it on this. So macro erupting an error, unexpected. Yeah, so let's add the remaining one. So this is how to convert it. So I'll just repeat this for the other one. So it's going to be this option here. Right, and now we are done, right? So this is how to create a simple CLI. So this is our first subcommand, right? And then I'll come down here. As I said, in case you want to specify it as a short form, so this automatically use H, but because I don't want to use H, I just go with R, right? So you can also change this one to H for human readable, right? And it, or R, right? So anyhow you want it to be. So H or R, it doesn't, you can decide for that. Then how do we use it? So to use it, I just come down here. Then inside my main function, we would want to call the value that we have there, right? So we have to call it to be able to use it. And then we simply do that by just going with here. So it's going to let, and I'll call it as a CLI. It's going to be my CLI enum, which is this one here. So then let's make it like this. I call it capital like this, but let's call it as CLI, right? Like this. And then this option here. Then I'll just go to see there is from args. Then now I can unpack them. So this is how to get all the values there, right? And once I get the value, I can now match them. So I can just come down and say my match CLI. So if the CLI is based on a CLI, so CLI, this here CLI here is the enum. If it matches the byte, as you can see, then I just pass in the value. Right, so this is the basic understanding. So this byte here, if there's a match, then I will now want to return something. So if there is a match, then return some value, right? So we can say if megabyte, then we can just do the conversion. So I can just do print line, then I can just pass in. So let's do print line. Right, I can just pass in some value that I want to pass in. So something like this. Then this is going to be my byte. Right, something. So this is a basic workflow, right? So I just pass in some value here in case I want it to be the byte. So something like this would be easy to do. Let me just do this. So it goes like this. So what you are doing is that, okay, if it is byte, right, if it's boolean, then we return this value. Else if it's human readable, then return this value, right? That's a basic workflow, and it works, right? Perfect. So now we need to define the functions to do the conversion. So we have two functions here, so byte to MB and byte to human readable. So we need to define those functions at the top. You can define it anyway. So let's define all the utility functions. So in the case of the bytes, I'm just going to create a function called bytes to MB, and this bytes, because you are converting bytes to MB, what we need to do is that we just need to pass in a simple function that does the conversion, and that is very simple to do. All I need is I need to specify that, okay, I want to get my number of bytes that I want, and then this is supposed to be 64, right? And I can return some value. So let's do a return of float, because this can also be a float. So float 64, and then I can just return the value. So we have the number of bytes. We need to cast it to 64 so that we can now divide it, right, by 124. This is the default size of every byte, .0. Then I can now multiply this by my default. So 1024.0. You can also use multiply by itself, right? So this is multiplication by itself, right? Perfect. And now we have defined the bytes to do the bytes to human enum. So it's going to be bytes to human enum. It will also be the same stuff, similar, but the only difference is that instead of this option here that we have, right, we have the same, but once we get the value, we need to do some conversion. So I just come down here and let's say, let the units that I want to be, we have a dictionary of the bytes. So B for bytes, we have KB for kilobytes, and then we have MB for megabyte, then we have GB for gigabyte, petabyte and terabyte, petabyte, and then so forth, right, as far as you wish. So this is all the units that we have. Then once we get the unit, we will just say let's mute the index be equal to 0. So we want to be looping through it. This logic is the same logic that you use for every programming language. Then I'll say that, okay, let my mute, the reason we are using mutable is that we want to be able to change it, right? The mutable is going to be number of bytes as float, just as we did here, the same logic as we have here. That's what I'm doing. Let me copy this, and then we now multiply it. So while the number that we have is less or equal to 124, because we want to be able to do, then we do another condition, and the index is less than the unit, right? So if it's less than this, just to keep it safe, -1, then I'll now divide it. So divide and assign. So divide it and assign to this 124.0. That is it. Then IDX then I'll keep on adding. Let's go to 1. That is all, right? So this option here allows us to be able to loop through the entire stuff. And why are we getting this 0 usize? We will now need to do some return. So let me take of this. We need to do a form of return. So the return is going to be format. Let's format the entire stuff, and then let's do this to 2. And then here, what we are trying to do is that we want to get the format again. Then we specify the number of units, and then the units, and then the sorry. Right, so sorry for this. And it's a basic workflow, right? Here we are returning a float, but here we are not returning a float anymore. We are returning a string. So we have to change this into a string, and then we get the issue first. Space. This is not supposed to be. This is supposed to be this, right? And it's fist, right? So this is a simple function. So one to convert it to byte, one to convert it to human readable, and now we can use it here, right? We can use the human bytes to human readable down here. Now let's see our function. If our function works, so I'll take off this. We don't need it anymore. So I'll come down here. So to be able to see if it's working, I'll just go down here. Then I'll just go with my cargo dash, right? Cargo run dash, right? That is use the current file, then dash help. And if everything works, it's it's compiling for the first time, then installing everything that it needs, and you can see that now we have gotten our values here. So we have gotten the bytes, and this is coming because we have an enum specified here. So this is coming from the enum here, because with enums we define sub commands, and then these are the values. So if I go down here and I just do my enum or my bytes, so we get the help, the readable, human readable, which we defined here, right? This is R here. That's the same thing R. So if I change this one to H and I write again, this is now H, right? So you can make it H, you can make it R based on how you want it to be. M is the megabytes, as you can see here, right? And then I can just come down here, and in case I want to run it and see if it works, I can just specify that I want to do my megabytes, then I can specify the value. And now we see that we get this value here. The reason we're having these warnings is because these are not used yet, right? So that is how to build a very simple CLI in Rust. Very cool, right? So that is how simple it is. Very cool, simple, useful CLI. Now let's write some unit tests for this entire stuff. So we see that we be able to build something simple, but how do you write a test? So there's a simple way you can write a simple test for this, and then we continue with AI. So I've given the structure of the code, and now I'll just go with. So to write a simple test for this, we mostly I can write the test in a different file, but let's keep it here. So this is going to be configure the test, and this is going to be configuring a test to be run inside this particular location, inside the mode. So mode test, right? And then here, so we use super, which is referring to the current file. So pick this, the scope, everything from the current file here, bring it into scope, and then now we can write our first test. So fn, let's test my bytes to MB function. And how do we test it? We just pass in the value. So asset equal, then I'll just pass my bytes to MB, and this will be, let's say 102 04, let's say 48 something, so 576. Then this will be probably 1.0 megabyte, right? So this is a simple test you have written, right? Perfect. This is good. We can also make it more explicit and add some absolutes for it. So that is something we can also do, right? And then once we do that, we need to tell Rust that this is a test. So we need to decorate it with my test, and then I can now run it. So to run it, so because I'm using Rust Analyzer, as you can see this from here, so Rust Analyzer, that's what I'm using. I can quickly click on this, and then it's going to run the test and see that the test passed. Right, so that's one way. You can also run a test like this, so cargo test, and then it's also run. Right, perfect. So these are the two ways you can run this. You can just click on it from here and run the test. Now you have seen how to build a simple CLI. Now how do we run it? As you could see, we have the test for the function, right? The individual function here. This simple function that we had here, right? These two functions. We can also add another one, another test for the human readable. Which is this one here. And then if I run this, so it's seen, okay, it failed. Let's see. Yeah, so the test failed. So the test failed, right? But you got the point, right? So how do we write a test for the CLI itself? So to write a test for the CLI itself, I'll just come down outside of my source in the same location as here. I'll create my test. Then inside test, I'll call it a CLI test .rs, right? And here I can use two packages to help me with my test. So the first package I can use to help in writing tests for CLIs is that you have to call, the name of the package is called access command, right? So I'll just import them, which is here, right? So we have access command, and then we have the predicate. In case you want to install, you can just see from here. You can quickly install it with this. So cargo add assets cmd, and then there's also for predicates, right? And then you can see that it's automatically added to our toml file here. Perfect. And then let's write our sample test. So to write a test, we can also use the same thing. So let's do it for the first test we had. So I'll just get my fn and I'll call it as my megabyte, our first test, and then I'll just create this. So this is how you do. You specify that you want a mutatable command using the command, and this is going to go with my cargo bin to build it. Then here I'll specify the name of the package, right? So Convertx. So this name is the name you'll be using here, right? So this, the name of the package together with this name here, right? So that it calls itself. Just as in case I want to run, I would have done something like this. So Convertx, then so bytes, something like this. So the test should also simulate the same idea, right? Then unwrap in case of nulls. Perfect. Then I'll go with my command dot arguments. Then I'll pass in the individual argument. So this is going to be a reference to that particular argument. So we have bytes, because that's what I would have called. And then I'll specify the byte was the first, then the value that I would have used, and then the other command, right? So megabyte. So because I would have done something like this, some value, right, m, this command. So exactly the same thing you are doing here, and then you just call, so cmd dot asset, then you specify that, okay, is it successful? And then if it's successful, what is the standard out, because we want to get this standard out we have. And then we specify that does it contain something, contains a particular pattern, right? So let's say it contains 0.0 MB. This is going to be right? So this is supposed to be this stuff here, right? Perfect. So that's how we do that. And then you need to decorate this entire stuff that we have with your decorator. Test decorator that is known as a test. And now if I run this, so now it's going to pass. It's compiling everything. And perfect. So we see that now it has finished, right? So we have the byte successful and then everything passed. Now how do you install this one to be able to build it to use it later, so that we don't need to be doing this is coming from the one I already installed, right? But in case you are in Rust, you would have done run, and then I'll just go with my byte dash m some value, right, to get some value here. But in case I don't want to be doing this and I want to run it out of the box, I will have to build it, right? I can just do the build release, and if I go with build release, it's going to build this package that we have. Then inside my target, inside my release, you have the package here, right? So you see I just finished building, and it is this one that you install, right? So you can ship this one for people to install in the system, or they can install it in a different way. So let's see. So perfect, so that's finished. And you see that this is the example, right? And I can install this one, or I can simply do my cargo install, then specify the path here. So this is going to install it globally, right? So that's how to build a very simple CLI in Rust. So we have seen how to build a simple CLI. So to recap, all you need is you need to import this is not needed. You need this one here from Structopt. You define your constant. Then to create subcommands, you just use Enum. You specify your subcommand and argument for your subcommand. This is used to tell it that okay, this is now an option. The short means use the first value, the long means use the entire stuff. You can also change the name if you wish, as you can see from here. And then we create our utility functions, individual functions, and then we use those functions in a match. So if the match is correct, we now pass in these particular values, right? So that's how to build a very simple package in Rust. So later on, maybe I'll try and see how to push this code somewhere. So thank you for watching. See you another time. Stay blessed. In case you want to also see me doing the entire stuff from scratch, you can check the next video below, right? See you another time. Stay blessed.